Okay. So for example, let's say we could graph this rational function. We can see that we're undefined at x equals to -2, correct? The vertical line is graphed by x equal to -2, goes right through the center. So you can see from the right-hand side, the graph keeps approaching it. It never truly gets there, but as we go closer and closer, the function itself shoots off really high. So the closer you get to that blue line, the forbidden point, right? The point that causes division by zero, the higher the functional value goes. So basically, as we approach from the right, the function goes to infinity. So we approach from the left, it goes to negative infinity. It just shoots downward. So that's the basic idea of what a limit is you just see, you find out the point. Right? Let's say I want to know, I don't know, x equal to 4, right? Here's 4. As we approach from the right, the function is going to point 166, right? 167 maybe. Approach from the left side, the negative side, the function is going to the same thing. So since from both directions, right, as we approach, let me get a symbol here. As we approach from this direction, the right side and the left side, let me draw that better. Right, we're actually approaching this x value down here, right there. So as we approach this x value, the y values are going to point, then we say 167, right? So easiest way to think about it, we approach from the right, we look at the y value. If that's the same as the value from the left, then we say the limit exists and we give them that number, 0.1667. If it doesn't exist, let's say there's a hole here, then you would just see what the function's doing. And it looks like it's going to 1.67. So you'd say the limit is 1.67, but the functional value would be undefined if there was a hole here. So what they're doing over here on the homework, uh, they they have this function. Let's go ahead and graph it. X minus 8 minus 9x plus 8. Okay. So look at the function. Similar to the last one. So they want to know what's happening as we get closer and closer to 8. So see this notation right here, right? This is saying the limit of the function as it approaches 8 from both directions, both sides. That's what this notation means. The limit of this as it approaches 8. Well, let's look at it. I don't know where 8 is, but we can just do this so you can get a clear point right there. So, what is that? Anyway, as we approach from the right side, it's undefined at the point. So if we zoom in, there's going to be a problem here. There's a hole. But as we approach from the right, the Y value is going to 0.1429, 0.1427. On the left side, it's going to 0.1429-ish. So since they're the same on both sides, the limit will exist. It's going to be 0.14, whatever we said. I don't remember. 29, I think. So what they're doing is having you plug in the values closer and closer to 8 on the left side, because 7.9, 7.99 is closer and closer to 8 from the left. 0.8, 8.1, 8.01, 8.001 is closer and closer to 8 from the right side. But we're not plugging in 8. We're just trying to see what happens as we get there. So you would plug this into the function. Whatever output you get, you put it here. Plug this in, etc. You just see what is the number changing into as I get closer to 8, which is what we did here. So basically, those outputs would be these values, closer and closer. So this is a, excuse me, um, what's the term? An analytical approach. Uh, sorry, numerical approach. So as we get closer and closer using actual numbers, we can kind of estimate it. So this is one of the techniques to find the limit. You just plug in numbers and see what happens. Okay. If they're different from both sides, then you would say the limit does not exist. So they have to be approaching the same thing in both directions. Does that make sense on what they're doing here or how they do it?
Yeah.
So it's the same nonsense over here. Although there is a formula here that you can use. Um, I think is created by the squeeze theorem or sandwich theorem. Let me show you. Here. So the limit as sin x over x goes to 0. They prove with the squeeze theorem that will always be equal to, where is it? Here. There's two special trig limits. This is in your book. I would make sure that this is on your formula sheet for your exam one. I would put both just to be safe. But basically, if the argument of sine matches what you're dividing by, then that piece will go to 1. That entire limit of this function goes to 1. This is basically just using your trig identities is another similar thing. So right here you can see, right, that this piece is actually gonna go to 1. So you can pull out the 3 in front. That's a property of limits if you look at the properties. This will go to 1, and then you'll have 1 times 3. So the limit would actually be 3. And you can graph it to see. Graphing is another technique to find limits. All right, so As we approach zero, you can see, right? It's undefined here. But as we approach from the right side, the y value is going to, do you see the number?
Yes.
And then the left side is doing the same thing. So since the left and right are going to the same place, as we approach the limit zero, the limit exists at 3, which we already know based on the squeeze theorem. But they're not actually using that here. I just wanted to show you that. It's going to come up later. They want you to use this method. Plug in numbers closer and closer to zero, see what number it approaches. And that number is going to get closer and closer to 3 as I plug these in to these x's. But do you see what they're asking you and what they're doing for number 1 and number 2? Is there any questions on what on why and what a limit is, or how do you know if it exists or not, and how to find it using this technique? Alrighty. Yeah, let's let me know. So this is all the same nonsense. So let's move on from this numerical approach. So here you're doing graphs, which is kind of what we've been doing. But check it out. As I get closer and closer to the limit 2, which is right here, right? As I get closer and closer to that point, what is the function doing? What y value am I approaching from the left and right? Yeah, the function is going to 4 as we approach 2 from the right side and the left side. Since they're both going to 4, we say the limit exists and we put 4. If they were going to different places, you would say DNE does not exist. You guys cool on 5. That makes sense?
Yes.
Alrighty, let's keep same thing. Let's keep going. Let's make this point make sense. So here's a piecewise function. They want to know if this is f, they're saying what happens to f as the limit approaches 1, as x approaches 1. Well, here's dx. So as we get closer and closer to 1, what's the y value going to? Yeah, you see how the limit is going to 2, but what is the functional value? The actual output at 1. Yeah, you notice how the output of the function is not the same as the limit, right? So whenever that happens, you would say that which we'll go into more towards the end of chapter 2, that's an example of a function not being continuous. But it does have a limit. The limit is 2. The function is 1 at 1, but the limit is 2 as x approaches 1. Any questions on the idea? Okay. All right, so you guys tell me on this one. What's the limit gonna be?
It's going to be 1.
Let's see. Do we approach from the left? Let's see here. Uh, one's right here, right? Approach from the right side is going to 1. Approach from the left side, it's going to -1, right? The 1 is right here for the x value. 1, 2, 3, 4, 5. Right here is 1. So as the x values approach from the right side, the function is going to 1 on top from the right side, -1 from the left side. So what does that mean?
Does not exist.
Yeah, the limit's not going to exist because they're not the same. They have to be the same from both directions. Okay. So whenever they don't match up, just put D&E. Any questions on 7? Okay, let's do another one. 8's very similar. 0 is right here, right? So as we approach from the right side, what is the limit? Just the right-sided limit. Then later they're going to ask you just one direction. What's the function doing as it go this way?
It's going
The
down
limit
to
is 0.
Yeah. You go from the left. That's going to be what? Yeah, it looks like 3. Yeah, I would say 3. So since they don't match up, right? Well, then it does not exist. So let me show you the notation really quick. This is 2.2. Excuse me. All right. So limit is x of 6 over 2 plus e to the 1 over x. So the one we just did, you saw the graph. Fix that. Sorry. Stupid thing. So the way you notate the limit um, from the right. Here, 1 second. Excuse me. Give me a moment. All right, excuse me. All right, so basically, if you're coming from the right, you should think the positive side. Um, so the limit from the right side of this guy is going to be 0, right? That's what we saw on the graph. Limit from the left side, you would say negative symbol. We said it was 3, right? So that's how you write the notation. I mean, you could write it in plain English too, but you should know what the symbols mean. Any questions on 8? That make sense? Is that weird? Okay, cool. Alrighty. Now it's similar stuff. So on 10, they want you to plug in the number. Do you remember what this notation means? Just in case you're rusty. Do you know what this guy means on this one?
Is it the X value?
Yeah, they're telling you to input the X value and give it the output, right? The function notation from college algebra, plug in 1. So output would be right there. Output is 5. So this is 5. At 4, we got a whole, but then it goes back to, actually, I think that would be undefined. So this one's undefined. There's just a hole there. So D and E, I guess. Whatever. B, though, is the stuff we're just learned right now. So we approach 1 from the left and right. Are they the same? If so, then the limit exists. So 1's right here. Approach it from the right side of the graph. It looks like it's going to what? What Y value? Yeah, it's going to be 1. And from the left, it's going to, looks like 7, right? What do y'all think? Looks like 7 to me. It's definitely not the same though, right? So you would just write D and E for B because they are not the same going. It's not the Y value is not going to the same place. Simple as that. For part D, we look 4 is right there. Approach from the right side and the left side. It's going to the same place, right? What number is that? Right. Y value is about 5. It's undefined, but the limit it goes to 5. The function does not. At least not there.
So C does not exist.
I'm sorry. For yeah, C does not exist or undefined. D is 5. A is 5. B is does not exist. Yeah, if it's open, usually we say does undefined. That's what we're supposed to say. Um, but I don't think that's an option here. If it does not enter, yeah, I think D and E would be our choice. I guess let's try it out and see what it says. Sorry, 1 second. There it goes. Yeah, so undefined or DNE is what they want. Since we don't have an option for undefined, use this. You guys have any other questions on 10? I think I'm going to move on to a different section. You guys cool on finding limits graphically? That makes sense. Let me know before I start focusing on other stuff. Okay. So this section, I need to fix these titles. This is analytically. So finding limits analytically basically means try plugging it in. If it works, cool, you're done. If it doesn't work, then you have to do some algebra to help you out. Okay. So on let me zoom in a bit. Number one, can I plug in -8 into x cubed? Is there anything stopping me from doing that? It doesn't cause anything to be undefined. It doesn't create a negative value in a root. So yeah, it's fine. Who cares? Just plug it in, whatever you get, that's your limit because that's your output. You can graph it to verify, but honestly, you don't have to if there's no issues plugging it in. So if you're able to plug it in and you get a value, that is your limit. The only time that's not true is when you have like weird piecewise functions. They're very strange functions. But just plug it in. Check out this guy. Can I plug in 1 without causing problems? What would you get? Yeah, it's 1/9, right? So since you're able to plug it in, well, that's the limit. That's it. You can graph it and then just see what the hell's going on at 1. Do the same thing we've been doing. Check out, is it the same on both sides? Cool. Oh, 1 second. Sorry. But yeah, if you can plug it in, great. If you graph it and you see it going in the same place, that's also another technique. So first thing you should always do is try plugging it in, then you're fine. All right. Same thing here. Can you plug in 3 for x? If you do, you get tangent of 3 pi over 4. Is 3 pi over 4 defined in tangent?
Yes.
Yeah, it's not a big deal. Plug it in, get your value. Cool. Move on. Same thing here. F is x plus 9, g is x squared. As x goes to 3, we'll just plug it in and see what happens. You can still graph these guys and do what we've been doing. For example, they said what is x squared doing as it gets closer to -4? Well, I do this just to have a mark on the graph. It's not, doesn't mean anything. But as you get closer and closer from the left, the y value is going to 16. As it gets closer and closer to the right, it's going to 16, but we kind of already know that because if you plug in -4 and square it, it is 16. So there's not much algebra to do here. It's just kind of like, plug it in and find out, see what happens. Part C is a composition, so you have to compose it and then plug it in, or plug it into F first, get that output, and then plug that into G and see what you get. Nothing crazy. But let's move on. This is where we actually have to do algebra. So the limit is x squared minus 49 over x plus 7 when x goes to -7. You can see right away, right? You cannot plug in -7 because you'll get 0 down here, correct? So if you do some algebra, how does the top part factor? This is a 6th grade question right here. Do you remember? Difference of squares back in the day. So these will cancel because these are all products. You can only cancel when you have products, right? I have to keep writing the notation because I haven't taken the limit. You can only stop once you've taken the limit. Plug it in and you get -14, right? So the limit is this. The simpler version of the function is x minus 7, because we did algebra to simplify the question. So right here, they want to see x minus 7. Over here is the actual limit, -14. Any questions on 5? Does that make sense?
For test purposes, is it okay if we write x minus 7 equals -14, or are you gonna want us to show you the step -7 minus 7 equals -14.
Are you asking like how much work to show?
Yes.
Well, I would like to see this cancellation. And skipping from here to here is okay.
Okay. Thank
But
you.
the more steps you show, the better for your, partial credit and whatnot. Because if you just give me an answer and no work, then it's meaningless to me.
Okay. Thank you.
No, I'm grading your work. Don't forget. I already have the answer. I want to see your steps and your thinking. If you get the answer wrong, I'm still going to give you the credit if you did your work correctly. Okay, number 6. This is another similar question to 5. The only difference is you use difference of cubes for the top instead of a difference of squares. Number 7 has you do it step by step. See how they factor first, and then it cancels and it becomes this, and then they plug it in. So basically the work that I showed, that's what they did. They just want you to fill in the blanks. Okay. Let's do 8. That one just looks a little harder, but not too much. Alrighty, I'm not going to write the title because the notation speaks for itself. All right. On this one, you're going to do the same. But you can't because you're going to get 0 on the bottom, so you have to do algebra to help you out. So this is what they mean by analytical approach. Factor the top. What does the top factor into? Do you remember? Right, the whole trial and error?
It's -4 and -9, right? No, wait. Is that?
Close. I believe it's +9 and 4. There you go. You just had the sign switched. So then they cancel. And this result is where you're going to plug in 4. Is there any questions on the algebra or what we're doing? Plug in the 4, and that'll be what? 4 plus 9 or 8, right? Excuse me. So first thing we did in 2.3 is just plug in the numbers, see what happens. The next thing we did was use factoring techniques in algebra to allow you to plug in the number and see what happens. Now this next technique is different. Whenever you see a square root like this, it's going to be a conjugate approach. Okay. You're going to multiply the top and bottom by the conjugate of the part that has the square root. Do you guys remember what conjugate meant?
That has to do with the binomials, right?
Yeah, kind of. Pretty much. It's like um, just two terms. For example,
Is that what the imaginary numbers or the real and complex?
it did come up there. That's a good memory. These are conjugate pairs. So yeah, you guys are on the right track. So basically, it's the same thing that differ, two terms that differ by a minus to these two, x plus 6, x minus 6. Two pairs that are both conjugates of each other. Okay, it just doesn't have to be exactly like this. It could be, for example, um, with this question, you need to multiply the top and bottom. So here's the technique. Multiply the top slash bottom, or the numerator and denominator, by the conjugate of the square root of 6, x plus 6 minus 6, which is obviously the same thing, but change the sign, right? This is one term. This is another term. So in the middle, you have a minus. So the same thing, same two terms, but with a plus. Okay. So you're basically creating or forcing a difference of squares to happen. And we're keeping the balance by multiplying the top and the bottom by this conjugate. So you see how these two will become a difference of squares, the numerators? So here we go. I advise you not to multiply the bottom part because it's going to get messy. You're basically, what you're really doing is forcing the top to become a difference of squares. That way you'll get rid of the square root and then you can plug in 30. Currently we can't plug in 30. So we got to hope that something will come out that will cancel this guy. Okay. So remember the difference of squares formula. If you multiply these, you always get a squared minus b squared, correct?
Yes.
So on the top, we're going to get that same thing. So you don't have to do the FOIL, all that multiplication, just use this, right? Save yourself some time. So square the first term minus the next term, because that's what the formula says, right? It'll become those two. So squaring this gets rid of your square root. Squaring the 6 gets you a 36. And the bottom, I'm still not going to do anything because I'm hoping to cancel the x minus 30. So I don't want to multiply it because I want it to get canceled. If I multiply it, then I won't be able to cancel it because it'll be distributed, which isn't helpful. What's 6 minus 36?
-30.
Yeah, it looks like we got what we wanted, right? Now we can cancel. So these will cancel out right here. Amount of space. So now you can plug in 30. Now, once you do, you should get right. So this is the second technique. First one was factoring. This is the conjugate. So you should always, I guess the zero technique would be just plug it in and see what happens. Any questions on number 9? Do you see how we forced this square to happen on purpose? Hmm. Okay. So let's look at the third technique, which I kind of already talked about. That's the sign type question. So remember we said that this has to match up perfectly with this. If they do, then it becomes 1. Currently, it does not. So you gotta do a little bit of algebra or using the limit properties. Hmm. All you have to do is purposely pull out the 6. Now you have the same argument. So the limit will become 1 times the 6. That makes sense? So note, this is the formula we saw earlier. The limit of sine x over x as x goes to 0 is equal to 1. And that's what we used here. All right, let's do one more. Here, let me show you. So here you just want to cancel things out until you end up with sine. So use your trig properties. Is this something you'd want to do right now? Does it seem doable or does it look hard for you? What do you think? All right, we'll move on then if you guys are good. Yeah, I suppose you're right. Let's go ahead and do it. It's theta, not x this time. Yeah, I remember with the some of the hardest math books I did in undergrad were always titled or the book always began with the term elementary. I'm just like, oh, okay. Bunch of BS that was. Okay, okay, so use your pre-cal to help you out. I'm sure y'all are pros at pre-cal at this point, but just in case. You agree that tangent is sine over cosine, right?
Yes.
So if I multiply that times cosine, what would happen? Right? These are gonna cancel, aren't they? So they're gone. But equals there. That's weird. Sure, we're all tired, so should all forgive ourselves. All right. This looks closer to what we need, correct? They need to be exactly the same though. So what do I need down here to use my formula? My argument x is technically a 6 theta right now. On the bottom, I do not have a 6 theta. So I need a 6. Yeah. So you'll need to introduce the 6 using algebra and then use your formula. I'm glad we did this one, right? So we get the limit as theta approaches 0 of 6 sine 6 theta over 6 theta. So just pull out that other 6 and then deal with it later. Now I can use my formula. Sorry. Is there any questions about the trig or the algebra or the limit property? Does this make sense? Okay, just let me know. Okay, check this one out. What would you do here? Because it's basically the same question we just did. I need this 6t to be down here, but I have a 5t. What would you do?
Would you use a reciprocal?
Reciprocal. Well, remember, whatever you do to the top, you have to do to the bottom. So you could, but you'd have a fraction on the top and a fraction down here. It'd turn into a complex fraction. I'm not saying it wouldn't work, but if we ignored the 5, what would we need again? So just to make it simple, couldn't I just pull out a 1/5 out here and then introduce a 6 over 6 like the last example? That makes sense or no? You guys able to do this one? Do you have any questions on how to approach it? All right. Well, let's stop here then for today. Do you guys have any homework questions? You guys doing all right so far? You got all the software working? Remind, Respondus, uh, any orientation problems?
I need help with that remind.